start talking about systems now. So nothing really changes, just that you have more moving parts. So graphing systems proceed the same way as before, but now you'll have multiple inequalities on the same pane. So yeah, it's gonna have to be careful. You must work with each, right? Work with each IQ separately and don't mix them up. Shading systems having multiple solution regions makes it difficult to determine the solution region. To make it easier, here it is. This is why I'm using reverse shading. To make it easier to determine the overall solution region, we use reverse shading. So you will sometimes ask me, Mr. Dirksen, do you want regular or reverse? This is what I'm going to tell you. I don't really care as long as you show me the solution region, the ultimate solution region, which is the area where all three, for example, if you look over here, it's where all three are true. So look at this one right here. You have three inequalities. I use Desmos for this. Technically, if you shade the true region and you have a bunch of shadings happening for every single inequality, you have something that is shaded. It would be the darkest region of them all. Okay, guys? That is your solution region. So now I'm telling you, you have to be super precise when you're shading to make sure that when you're said and done, you can identify the darkest region in your graph, which is extremely difficult. Even if you take your time, it's going to be hard because everything is going to look the same. That's why I will introduce reverse shading. So what we do is we shade all the false regions out. So whatever isn't shaded is our solution region. Okay, that's why I'm doing it, just to make it easier on ourselves. If you had a computer software, I would stick with regular shading any day. But we don't have that, so I'm going to introduce this. Okay, so let me use orange maybe. Okay, this is the solution region. Okay, the solution region. Okay, hard to see. Hard to see. So I'm going to use this format here, and this is the solution region. In the past, in Intro to Applied Pre-Cal, you did a system, but you would focus on finding the point where all three of them intersect. Now we don't care about that. Well, we do care about the intersections, but we find the area, the solution region that we want, right? We use reverse shading, and I most of the time will indicate that. Okay, let's keep going here. Points of intersections are the corner points. I think you've already done that. So these are the POIs right here, where the all the boundary lines where they meet. These are the POIs. Okay. Over here, so there are three POIs here. Okay. Three instances where boundary lines meet. Versus over here, you only have one. Right? The two boundary lines only meet once. So these two only one POI. So don't be thinking that when it crosses the x-axis or the y-axis that's a point of intersection. It's not. We don't consider that now. Later with word problems, it'll change. So this is my solution region. And this is my solution region here. I want you to identify that, because if you use reverse shading, especially, then we need to identify that, hey, We used reverse shading, but this is our solution region, and that's what matters ultimately. All right, let's graph one system. Graph the following system of inequalities, then identify the solution region on the graph, include POIs. Is it a good idea to graph all lines on the it is a good idea to graph all lines of the calculator before graphing it on paper, since the POIs might be outside the grid if you don't do so. We'll get to that in a bit. Look at this. These are your two inequalities. This is IQ1. This is IQ2. And the textbook has some of these, and I think the province also wants you to be familiar with it. All you want to focus in on is the actual inequality, this part right here. Okay. Don't worry about the rest. This is just a way of presenting an inequality, one way of doing that. So you introduce the variables present, that's x, y, then the actual inequality, and then you're going to say x could be all numbers in the real number set, and y can also be any real number you can think of. That's all that is happening here, so don't let that confuse you. All right, so let's do one at a time. I'm going to do IQ1. You got to be organized. I'm going to try to give you space, but you still have to be conservative, okay? So I'm going to take the 4x. I'm going to bring the 6y over, and then it's greater than 12, okay? So I've rewritten it a little bit to have my x, y, and number like that. I believe this is in standard form. There's general form, and then there's standard form. I don't know if you remember that. So the first thing I do is I tend to find my intercepts. This is for graphing purposes. Okay. So using this one that I've rewritten, it's 4x is equal to 12. Divide both sides by 4. X is equal to 3. So 3, 0. There we are. That's my x-intercept. For my y-intercept, the x turns into 0, so it's negative 6y is greater than 12. Sorry, I just go with the equal sign because I'm considering the boundary line formed by this inequality. So we just divide both sides by negative 6. Y is equal to negative 2. So 0, negative 2 is my y-intercept. Box that in. Nice and neat, tucked away. Next, I rewrite. And I've been preparing you for this, right? I've been asking you to find the intercepts, rewrite. And so I'm doing the same thing. And you can do it in the order you would like. So 4x minus 6y is greater than 12. I'm going to bring the x over to the other side. So you end up with negative 6y is greater than negative 4x. And the 12 is already there, so I'm just going to go plus 12. It doesn't change its sign. Then you divide everything by negative 6. And this should ring a bell. When you divide by negative, you have to change that sign to keep this statement true. So we just make it right, flip it the other way. So I don't know. I tried to make it obvious in my notes, right, that we're doing that. So I'm just going to go arrow like that. And so that's y. And this is 4 over 6x, right, positive, minus 2. And this jives with what I've done before. The negative 2 and the negative 2 are good. So I know I'm doing things right. I'm going to box this in because I do look for this. This is going to be a full mark. Actually, 2 marks when you have to flip the sign. And so we know that this is going to be dashed. Make sure you do this part. You tell yourself, I know this is dashed, that the true region is where? If it's less than, it's below. And here's where it's going to change. I'm going to use reverse shading. I know true region is below. That doesn't change. But I'm going to shade above. Okay? This is important that you make note of that. Reverse shading. Why are you doing reverse? Because it's easier to find your solution region. So whenever I do more than one inequality, I automatically switch over to reverse shading. Okay. Let's do the same thing. I'm not graphing at all. I'm just going to do the same thing with that second one. It's almost like two questions in one. So let's go ahead and do that up here. I'm going to clean this. I guess we can go IQ2. I'm going to clean this one up because it's not in the format that I would like it to be. So I'm bringing a 2x over to the other side. So that would be positive 2x plus 3y is less than or equal to 9. That's how I'd like it to be. I find the intercepts. X-intercept. And I'll say this, if I can make it look pretty organized, you can do it too. Okay, because my that was the biggest complaint from my teachers was like, I can't read what you're writing. So there we go, 4.5. And then for the y-intercept, you're left with the 3y is equal to 9. Mr. Erickson, why are you doing equal signs? Because remember, I'm considering the boundary line for this inequality when I do this, because I'm interested in graphing that boundary line. So you turn that inequality into an equal sign, just considering the equation. Divide everything by 3. Y is equal to 3. That's 0, 3. Boom. There you have it. Let's rewrite. So I'm going to go 3y is less than or equal to negative 2x, because the x comes over to this side, plus 9. Divide everything by 3. I don't need to flip anything because I'm not dividing by a negative. This is simply negative 2/3 x plus 3. Okay. Before you do anything, I do this every single time. You'll see this on my key. I know this is going to be a solid line, because when you graph 2 or 3, you just want to have to go back to this and just see, am I doing this right? Solid. The true region is, it's y is less than. And you're like, wait a minute, am I doing this right? What did I do with the other one that I just did? Was also less than, correct? And you said true is below, so that better jive, right? If they're facing the same way, your true region should be in the same region, so make sure you check that. I'm going to shade above. This is reverse. If we had done regular shading, we would have also shaded below, just like the true region is. And let's go and graph this now, one at a time. I encourage you to grab your calculator and first enter these, graph it on your screen, and see what you're expecting, just to make sure we include all the points. So y equals, so brackets, okay? 4 divided by 6, close the bracket, x minus 2. And then I do this again, bracket, negative 2 divided by 3, close the bracket, x plus 3. And let's hit graph. The y-intercepts are small. I'm expecting everything to show up just fine. However, I'm going to do zoom standard because I want to see if it fits into a 10 by 10 by 10 by 10, right? So I'm going to go zoom standard. Yeah, it does the trick. So, Mr. Dixon, what are you looking for? Where they meet and all the intercepts. Then you're good. Okay. So that's a pretty good window. You know it's going to fit. So label X and Y, right? And I'm just going to go 5, 10, count that there is 5 boxes because some of my grids are going up by 4s, right? So you got to watch out. So these are 5s every which way. And then make sure you go -5, -10. So you've identified your scale. And one at a time. So stick with this one here first. So 3, 0, put a point down. 0, -2, put that one down. Grab your ruler. Does it make sense that it's pointing up? I'm going to do a quick check. My slope is positive. So yes, that's what I expect. So I'm going to go dashed. Arrowheads. Label it on one of the ends here. It's up to you which one you want to use. Don't shade yet. In fact, the main reason why I don't want you to shade yet is because if you make a mistake and you find out later, it's a mess, right? Like you're now like smudging everything. And so do this one first. Then I'm going to go to my next one here. 4.5, 0, 3. 4.5 is right there. 0, 3 is right there. Does it make sense that my line is decreasing? It does because my slope is negative. And this is a solid line, right? Don't be shy. Go extend past the grid. There's no problem with that in this case. Later when we do work problems, then you do want to stop, depending on the context. So you've got both lines. Now, let's start shading. So I'm going to start with the very first one. This one matches what's on my screen on the calculator. I'm fairly confident this is it. We're told to shade above, right? This line, this first inequality here, we're shading above. So let's go ahead and do that. Then you grab the second one and you just go look. Now you've done all the work already when you were working with it. So we're also shading above. So we grab our ruler, we line it up, and we go ahead and shade. So it's everything above that line. All of that is gone because we're shading out the false regions. We're saying this is not it, this is not it, these are all not it. So what you're left with here is this is where it's very important to make sure you label that solution. Right? That's short for solution, by the way. The little n exponent. So that's how you do it. So any point inside this region is part of the solution. Any point on this line would, like starting I guess here, any of these points would also be part of it, but any points on this line would not be part of it. So that's something to consider here. Let's figure out our points of intersection. We only have one. I'm gonna label that red with a red pen. That is what we still want. That's what we call the POI. There's only one in this case. We already know how to find it because we've already entered this. So just go ahead and find it. Second trace 5. There's only 2 lines, so you just hit enter 3 times and you're good. And that point is 3.75 and 0.5. That one is going to be very important to us down the road. And because you're showing a lot of work, your graph and all that, you don't have to show keystrokes. But if you just want to do that anyways, it doesn't hurt. I would be okay with just saying second trace intersect. That would be good for me, good enough. That's how you do a system. It's just a bunch of inequalities at the same time. But we're interested in the solution region. Okay? Anything in here is true for both. So let me ask you this. And remember, this could be asked of you without a graph. Okay, keep that in mind. So if you feel like I'm doing this, it's kind of repetitive, you're like, I already know the answer, just remember, I may not give you a graph, you may not have one. Is 4, 5 a solution to the system? Let's go find it. 4, 5 is up here. We already know it's not. Okay, but we're going to sub into both inequalities. Okay, so here we go. The first one, I'm going to use the original. This is the 4x is greater than 6y plus 12. So let's sub in 4 and 5. X is 4, y is 5. So it's 4 times 4 is greater than 6 times 5 plus 12. That 16 is supposed to be greater than 30 plus 12. 16 is supposed to be greater than 42. This is false. Technically, you stop. Not a solution. Because it has to be true for all of them. But let's say you turn into, like, you get a true here. You got to keep going until you see a false. Okay, so let's try again here. This one is the 3y is less than or equal to negative 2x plus 9. Here you have to be careful. Y is 5, correct? So this will be 3 times 5 is less than or equal to negative 2x, which is 4, plus 9. That's 15 is supposed to be less than or equal to negative 8 plus 9. 15 is supposed to be less than or equal to 1. This is also false. Therefore, 4, 5 is not a solution. Has to be true for all inequalities. For it to be a solution, you would have to do this for as many inequalities as you have, and it has to be true for every single one. Okay. 1 second here. Okay. I want you to go to 31. You're going to try 31. 31 is less work. Do you notice a special case? Page 31. That one is very simple and quick. So do everything you've done before, intercepts, rewrite it, find where the true region is, do all of what we've done, and graph this and see if you can do it. Okay. I want to try to do 32 if time allows, but I want you to have a go at it before we continue. If you ever want to graph a vertical line, this is the trick, and you might have to add this to your study sheet. Y1, you already have that probably, but Y2, let me see if I remember. I think it's 9 nines. Okay, so you gotta go 1, 2, 3, 1, 2, 3, 1, 2, 3. Don't ask me, I just YouTubed this one day and it works. And you gotta go X, and whatever sign is here, you gotta use the opposite sign. You'll find out if you get it wrong. But if it's positive 4 there, we're gonna go minus 4. X minus 4. And then you hit graph. And it will graph you a vertical line. For years and years, I told students it's impossible. And then I YouTubed it and someone figured it out. So that's how you do your vertical line. So one more time, 9 nines, and then it's X plus or minus whatever value you have. Okay, so maybe I'll add that to the notes here. Don't buy lead from Dollarama, okay? Not good. To graph vertical lines, we go y is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9. And then it's x minus the number. And if you go minus, you will always get it right, because if this is negative, if it's negative 4, then you go x minus negative 4, and it ends up being plus 4. Right? So y is equal to 9, 9, 9, 9, 9, 9, 9, 9, 9, x minus 4 in this case. And then you can find the, you can actually graph it. Add this to your study sheet under inequalities, because it shows up most often in this section. Yeah. The alternative to this would have been second trace 1 value, x is equal to 4, and then you find where it hits the other line. Okay. I'm just doing this quietly here. If you want to keep working, that's just fine. going to shade right on that vertical. Yep. Shading right. Shading below. How to find the intersection? For sure. Let me shade this. There you go. So satisfying. Sometimes just shading it away. Okay. This is your solution here. This section here. POI to be determined. So I've entered them both. And then I just go second, trace, and there's intersect. And so if you have two lines, it's just enter, 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 and it will find it. Sometimes it's way up on the vertical. You don't see the cursor. Don't worry about it. When you just have two lines, that's what it is. So this one right here is for -2. I'm just going to say the POI is for -2 here. Second, trace, intersect. There's only one. There's only one. Is -720 a solution? Let's check here. -7 is here. 20 is way up here. It is going to be, right? Visual examination tells us that it is going to be. I will leave that up to you, though, to actually plug in and make sure both of them are true. I'm going to ask you to do 32 and 33 for homework, but don't pack yet. For 32, it's a trickier case. Okay, let's go to 32. It's not really that tricky, but you just need to watch out. I will actually say tricky. Tricky situation on this one. Okay, why is it? Both intercepts are 0, 0. Like if you do the intercept thing for this, you're gonna get 0 for both, and it's not. So it's 0, 0 for both. Like I need 2 points that are not the same to graph this thing. That's when you do this. Okay. First of all, we don't like it the way it is right now, so we're gonna bring this one over and this one over. So we're basically doing a dance there. So when the y comes over to the left, it goes negative. When the x comes over to the other side, it also goes negative. The sign is still the same for now. You're going to graph this yourselves, though. -1, divide both sides by -1, and then hold it, right? We're going to make this face the other way. So it's y is equal to positive x. So that's the one you want. What do we know? This is dashed. True is above. We're going to shade below. This is what you want to focus on for graphing purposes. But how are you going to graph this? Entering this into your calculator is not a big deal. It's just x, right? So point number one, point one is going to be 0, 0. No doubt about that. Point number two, you pick. Usually choice is good, but students don't seem to appreciate this one. Okay, so this is what you're going to do. Let x be what? What would you like it to be? And you got to be smart within the context. So because we're probably going to stick within this between like a 10 by 10, I'm going to let x be 5. Therefore, if that means that if y is equal to x, if that's the boundary we're considering, if you let x be 5, then guess what? Y is going to be 5 as well. Therefore, your second point is when x is equal to 5, y is equal to 5 also. So here's point number one, point number two, and now you can graph it, no problem. If you're scratching your head a little bit, that's fine. We're going to see more of these, okay, down the road. So you need to be smart and pick, just make a value yourselves. So page 32 and 33, please. I'm not asking for crazy much, right? But I do need you to do, I'd rather you do 2 questions than you assign 10 and you do none of them, right? That's why I try to keep it, for the most part, reasonable, okay?